Hey, welcome back. This is section 3.4 on slope and rate of change. So we've seen slope before, we've kind of talked about it a little bit, but we will kind of dive into it deeper today. So let's first look at what it is. We're going to start with a graph. I'll do my best to draw this graph. Okay. Alright, not too bad so far, right? Let's say I have let's see. I'm going to change that. I want it just like this. Okay, let's say I have a line that goes through these 2 points. Alright, kind of goofed up my line there, but let's say I have these 2 points. On this line, this point here, let's say is 1, 2. And this point here would be 1, 2, 3, 4. 1, 2, 3, 4. Alright. So, slope is the rate of change. They're the same thing. But it's essentially the steepness of the graph. If we're looking at something graphically, it's how steep this graph is, right? And it can be measured by the rise divided by the run. Meaning how fast it goes either up or down, divided by its left or right movement, right? So since I have 2 points here, I can figure out what my rise and run are between the 2 points. So between, say, this point and this point, I can go up 1, 2, and then over 1, 2, 3. Right? So my rise here is 2, and it's a positive 2 because it goes up, and then my run is 3. So the slope of this line is 2/3. It's 2 over 3. And that's essentially the graphical version of what a slope is. Let's take a look mathematically. If we didn't have to go, if we don't want to, and we typically don't want to rely on graphs very much, but if we didn't want to look at the graph in order to do this, and plus it's pretty lopsided because I drew it anyway, there's a mathematical way to find this, right? This rise is considered to be a change in y. I'm not going to have enough room here. A change in y values, right? It's your y values go up and down. It's your right. It's how much you go up and down. It's your change in y. And your run is the change in x. It's how far over you have to go to match that, to get back on the line after you've done that change in y, right? But the change in y is simply your new y minus your old y. So if I write this, and we're going to, instead of writing slope every time, it's very customary to write slope as m. And since this is the change in y, I'm going to write this down here, divided by the change in x. But the change in y is like the y of the second point minus the y of the first point, divided by, and then my change in x is the x2 minus x1. The x of the second point minus the x of the first point. Where I've simply designated my point up here as my second point, so it's x2, y2. It's the x and y value of point 2, and the first point I'm simply calling x1, y1. It doesn't matter which one you call x1, y1, and x2, y2, as long as x1 is hooked up with y1 and x2 is hooked up with y2, because that simply denotes which point. Right? And so this the equation right here becomes the slope formula that we'll use. So let me erase this a little bit and get a clean slate here. There we go. That means that I can find those points. Let's say I have a line goes through 2 points, let's say 2 and 5 and 3, -2. Right? If I want to find the slope, that m is y2 minus y1, the difference in my y's, over x2 minus x1. Right? And all I have to do is just decide which one of these is going to be point 1 and point 2, and again, it doesn't matter. I'm going to call this one x1, y1, and this one x2, y2. Right? And so y2 is -2 minus y1, so -5, over x2, which is 3, minus x1, which the denominator is actually a 1, and therefore my slope is -7. Right? Okay. Let's look at a couple of problems here. Let's find the slope of the line that goes through the points, let's say 2, 5, and 6, 1. Okay. So again, I just have to identify one of these as point 1, so I'll just say x1, y1 because it's first, no other reason, and x2, y2. Okay. Recall the slope formula, that's m equals y2 minus y1 over x2 minus x1. And therefore that's y2, which is 1, minus y1, which is 5, over x2, which is 6, minus x1, which is 2. That's a weird looking 2. Real 2, right? Not that fake one. 1 minus 5 is -4. 6 minus 2 is 4. -4 divided by 4, that's just -1. So my slope is -1. Good. Okay. We'll see also that we have the slope-intercept form of a line, y equals mx plus b. If you have an equation written in this form, that m right here is the slope. And this b right here is the y-intercept. So we can do a little bit of that, right, with that. But if I have something like that, say it's y equals 2/3 x plus 5. The nice part about this is if I'm asked to find the slope, it's just right there. That slope is 2/3. Right? The intercept right here, this tells me that my y-intercept happens at 0, 5. Right? The y-intercept always happens at 0, b, and so whatever that b is, if it's 5 in this case, then my intercept is at 0, 5. So if I'm asked to find the slope of a line, it's very convenient to put it into that form. I might be asked, for example, to find the slope of a line that's given to me in standard form. This one, for example. So I really just want to solve this thing for y, to put it into y equals whatever ends up being over there times x plus something else, right? Y equals mx plus b. So I'll subtract 2x to start from both sides. We like to typically see this 2x in front of the number, so I'll put it in front. This leaves me with 7y on the left-hand side, and I'll write minus 2x plus 21 over here. And then I'll divide everything by 7. This leaves me with y on the left, negative 2/7, and I can push the x out of this and off to the side there. And then 21 divided by 7 gives me 3. So what is my slope? My slope is negative 2/7. The intercept happens at 0, 3. So I have those two bits of information. And they're very powerful bits of information. We'll see a little bit later that it's extremely convenient to graph this in this way. Okay. What about the line y equals 5. We've seen this in the last couple of sections. We know what this looks like. It's a horizontal line that just happens at 1, 2, 3, 4, 5, right? So what is the slope? Well, it doesn't ever go up and down, right? So in fact, if I pick 2 points, I have the point 0, 0. And I have, let's say I have this point right here, which is 0, 0. That's not 0, 0. That's 0, 5. And then I have this point over here, let's say that's 1, 5, right? And if I write these, let me write these right here. I have 0, 5 and 1, 5, okay? Now if I call one of these x1, y1, and the other one x2, y2, I can plug it into the slope formula. That is y2 minus y1 over x2 minus x1. And y2 I've designated to be 5. y1 I've designated also to be 5. x2 is 1, x1 is 0. So 5 minus 5 is 0, 1 minus 0 is 1, 0 divided by 1 is 0. So my slope here is 0, which means I don't go up, I don't go down. No matter how far left or right I go, I don't go up or down ever, right? Which describes a horizontal line. So horizontal lines then have slope 0. So that's a horizontal line. Let's take a look at a vertical line. We know what those look like. They are when x equals something, say 3, doesn't matter, right? I know what that graph looks like. 1, 2, 3, and it's just that vertical line at 3, right? So we know what that looks like. I have some points here. I can say there's a point there at 3, 0. And I can just go up 1 and find a point at 3, 1. Once again, I'm going to call one of these x1, y1, x2, y2, and plug it into the slope formula. I'm going to put y2 minus y1 over x2 minus x1. y2 is 1. y1 is 0. x2 is 3. And x1 is also 3. That gives me 1 in my numerator, but 3 minus 3 is 0. And here I have issues because I can't divide by 0. This is undefined by definition, which is a weird way of saying by definition it has no definition, right? But it is, it's undefined, so a vertical line has an undefined slope. Because of the way that the slope is defined to be the rise over the run, it would require us to divide by 0. So we get an undefined slope. Okay. Board is moving all over on me here. If I have two lines, let's say that look like this. You can see that I tried to make them parallel. I did a pretty good job, I say, but these two lines were parallel, and we know that they're parallel because they'll never cross over each other, they never touch, or mathematically speaking, we would say that their slopes are the same. And so these are indeed parallel lines. And they have the same slope. Necessarily, they have to have the same slope in order to be parallel lines. Likewise, if I have, let's get rid of this line. Let's say I have a line that intersects this line at a 90-degree angle. These two slopes are tied together. If one of these lines were to change, in order to maintain a 90-degree angle, the other one would also have to change, right? And the interesting thing about these angles is that they cause the slopes of these things to have a partnership, but this is that partnership. Parallel, not what we're talking about. Perpendicular. These perpendicular lines have this relationship. If I pick a point, say here, and I go up and over, and I pick a point here, and I go down and over, right? It may not be obvious because I can't draw worth a darn. But these triangles are the same, they're just rotated. Meaning, if this has a huge rise, let me draw this again actually. Let me show you a more exaggerated example so that this will become more obvious. Alright, so let's say I have line 1 is fairly shallow. Okay. Then to be perpendicular, where should I draw this? There's my right angle. So if I have 2 points on this guy, I just have to go up a teeny bit and over, right? Let's call this maybe 1 and 3, right? I don't know if it is or not, it doesn't matter. But if I have these 2 points on this guy about the same distance, this over would be the 1 and this down would be the 3, right? So it's the same triangle, it's just been rotated, and instead of going up, I have to go down, right? So if I rotate up and over, right, rise, over run, to get the parallel, or to get the perpendicular one, I just flip these guys. My rise becomes my run becomes my rise, and I also flip directions. So that is to say, these perpendicular lines have a negative reciprocal. Relationship. Okay. I'm going to erase this and write it a little bit better, more mathematically. Let's take a look at this here. Suppose line 1 has a slope of a over b, whatever that fraction may be, a over b, right? A perpendicular line has slope of negative b over a, right? So you do two things. You switch, you flip it upside down, a over b becomes b over a, and it becomes negative. If it started out negative, it becomes positive, and that's your perpendicular line, or your perpendicular slope. Okay, that's it for this one. Thank you, and I will see you guys for 3.5.